My name is Brian Clark. I'm a junior electrical engineer at Yale, and I'm president of the Yale Undergraduate Rover Association, as well as the electrical team lead. We've made a lot of improvements this year with our electrical subsystems. Everything from communication to power distribution have been improved. We've lowered the frequency of our transmission signal from 5.6 to 2.4 gigahertz, which should give us better range throughout the competition. Additionally, we've lowered latency. We're still using the same C920 Logitech webcams for our Rover's vision. We've got latency down to about a tenth of a second.
Alright, so here we have a rough layout of all our electronics that are going to be on board the Rover. This year we're using our generous sponsorship from ProtoCase to machine a custom-made electronics enclosure to go on the back of the chassis. Now what we have here are three separate levels of the enclosure. It's currently being machined, so we don't have that to show you, but it's going to be divided into a power distribution level, motor control and drive level, and a communications level.
Hi, my name is Patrick Wazinski. I'm a junior mechanical engineering major, and I'm in charge of the mechanical sub-team. The mechanical sub-team this year has been focused on improving our design from last year. Last year's design worked, but it didn't work as well as it could have. So we've been focusing on simplifying and paring down the design to improve it. So this is the wheel design that we used last year. It has a commercial beach wheel coupled to a motor outside of the wheel. So this design had a lot of issues. One of the biggest is that, as you can see, it has a giant footprint and very little of that is actually the wheel. So as we'd be driving along, the motor could hit rocks or any obstacles and the wheel wouldn't be able to traverse them. To address these issues, this year we're making our own custom wheels. This allows us to put the motor completely inside of the wheel, which will protect it from rocks and also decrease our footprint. In addition, we'll be able to custom tune the grippiness of the wheels by putting on our own treads. So this is our suspension. It's a rocker bogie suspension, and it's based on the same design that we used last year, which we found was very effective in traversing the terrain. So it's the same suspension that's actually used on NASA's Curiosity Mars rover. And how it works is you've got the front bogie and the back rocker, and they move independently of one another. And then they're coupled to the other side through this differential bar. And so as one side will go down, the differential bar moves back, and the other side goes up. And this keeps all six wheels on the ground at the same time.
Hi, my name is Adit. I'm a sophomore computer science major here at Yale, and I'm in charge of software for the rover. We have three main systems. We have a system that runs on a laptop that's controlled at a ground control. Then we have a small piece of software that runs on the rover that controls the motors and the sensors. Then we also have an Arduino on the rover, which controls some of the servos in the arm.
So if you take a look around, this is our wet lab here in the CEID, where we do a lot of work for the rover. As head of the Earth Science team, a lot of what we're focusing on is more the science capacities of the rover as opposed to the mechanical or software aspects of it. So we purchased several instruments that we're going to be using at the competition to analyze our samples of soil that we're going to collect. First off, we just have a simple scale to measure what we pick up. We know all the samples need to be greater than 5 grams. Over here we have our HANA Instruments 99121 pH meter. It'll measure pH directly from the soil, which is very important to us. A lot of pH meters, they work by measuring pH in solution, but this pH meter actually works by weeping out solution through the electrode. So all we have to do to get it to work is turn it on and then insert it directly into the soil, and then we'll end up getting a reading. And our last instrument here is our Anscope MD130 microscope camera. Once we return to our base station with our samples, we'll be analyzing it with the microscope, and because it allows us to connect with the computer, we're also able to take pictures of each of the samples that we get.